This is for Year 12 Specialist. It comes out of 9A question number 4. If this differential equation that involves a second derivative and a first derivative and y has this solution, find the possible values of n. Okay, what I need to do is to take the first derivative, replace it, take the second derivative, replace it, and then explore what's happening over here for the values of n. So y equals ax to the n, therefore dy dx will equal an x to the n minus 1. And the second derivative will equal an times n minus 1 x to the n minus 2. Okay. So I've got x squared times the second derivative. So x squared times the second derivative, a times n minus 1 times x to the n minus 2 minus 2x times the first derivative, so times this, an x to the n minus 1 minus 10 times y, which is this, ax to the n equals 0. So x squared times x to the n minus 2, I add the powers, so that gives me x to the n. And I've got an times n minus 1 of them, minus 2, x times x to the n minus 1 is x to the n. I've got a times n minus 10a x to the n all equals 0. So I've got a common factor of x to the n in all of these. I've also got an a in all of these. So if I take the a out, I've then got n squared minus n. The a's gone out, the x to the n, so minus 2n minus 10 equals 0. N squared minus 3n minus 10 times x to the n equals 0. I can crisscross that 2 and 5 with the negative on the 5. So what have I got? I've got a times n minus 5 times n plus 2 x to the n equals 0. Okay, this will only happen if a equals 0 or n equals 5 or n equals negative 2, and that can never give me a 0. Since the question said what are the values of n, then n can only equal negative 2 or 5.